Hey guys, this is Preston with the DLASC. Today I wanted to go over a couple of examples, some early Calculus 2 integrals. I picked a few problems that had some techniques that I think a lot of students don't run into very often. I just want to make sure that if you're watching this video, you get exposed to it. Also, I think that these particular integrals are really fun. So yeah, let's go ahead and get started. The first one is going to be the integral of 12 divided by e to the negative x plus 1 dx, just like that. And so to get started, what I'm going to do is I'm going to pull this 12 out of the integral. Okay. Now you might be looking at this and go, okay, well, can we use u substitution? Well, what are you going to make your u? Whether you make it e to the negative x or whether you make it the entire denominator, you're going to end up with a negative e to the negative x that we don't have in the integrand, and we can't deal with. We can't package that back up into differential x. So what I'm going to do is a really cool trick where I'm going to say, okay, well, 1 is the same thing as 1 plus e to the negative x minus e to the negative x, right? That's the same thing. I mean, 1 plus 0 is equal to 1, right? And e to the negative x minus e to the negative x is equal to 0, right? So I'm not breaking any rules here. I'm just kind of restating that that numerator in a way that is going to be useful for me. So now what I'm going to do so I'm going to go ahead and say that this is equal to 12 times, let's see, the integral of, I'm going to rearrange this first part so that it's obvious, right? Plus the integral of, or actually, we'll go ahead and pull the negative out here, minus e to the negative x over e to the negative x plus 1, like that. Okay, and now it should be pretty clear that this reduces to the integral, oops, forgot my dx there, don't do that, to the integral of 1 dx minus the integral of e to the negative x over e to the negative x plus 1 dx, just like that. And so now, hopefully you can see that u substitution will work over here on this integral on the right, right? Because if you let u be equal to e to the negative x plus 1, du is going to be equal to negative e to the negative x dx, right? So I'm just going to go ahead and do that mentally because it's really not that bad. This is going to be 12 times x minus the natural log of the absolute value of e to the negative x plus 1, right? Plus c. And there we go. That is integral number 1. Let's go ahead and do the next one. We'll probably do one more for this video. And it's good enough. We'll actually just move down here. There we go. Okay, so the next one I want to do is going to be the integral of x squared divided by x minus 7 dx. Okay, now this one's interesting. I'm going to start off by saying that I'll do a u substitution. Let's do u equals x minus 7, okay? So let's pretend that this is the first time I've ever seen this problem, and I'm just giving this a shot. There we go, that's better. Well, that means that du is just going to be equal to dx, right? Because if we take the derivative of x minus 7, we end up with the derivative of x dx minus a constant, right? So that constant's going to go to 0. We're going to have du equals dx, right? Okay. Now let's look back over here and think, well, if we put u there, I mean, the derivative doesn't provide us x squared, right? So we're not going to be able to do just a straight up u substitution because there's more dependent variables in the integral than what we'll be able to deal with if we do so. But what we can do is something that you might not think of immediately, but it makes a lot of sense. Okay, if u is equal to x minus 7, then x is equal to u plus 7, isn't it? So then if I put everything in terms of u, well, let's think. This would be integral u is equal to x minus 7, right? So my denominator is going to have u. And then my numerator is x squared. X is u plus 7. So this is going to be u plus 7 squared. And then dx is du, right? Okay, so now that we've gotten that far, let's go ahead and let's just FOIL out u plus 7 squared. That's going to end up being u squared plus 14u plus 49. And this is all over u du. Okay, I'm going to go ahead and break this up. This is going to be the integral of u squared over u plus 14u over u plus 49 over u du. Okay, now I like to go ahead and break everything up into separate integrals. So I'm going to go ahead and do that. And I'm also going to go ahead and notice that these can be reduced a little bit, and I'm going to do that along the way. So the integral of u squared over u is the same thing as the integral of u du, right? Because the u's cancel, okay? So then we're also going to go ahead and pull this constant out of this second term first. So it's going to be 14 times the integral of u over u, which is trivially 1, right? Du plus, I'm going to pull the constant out again. This is going to be 49 times the integral of 1 over u du. And hopefully you all recognize that that's going to be natural log. So let's go ahead and wrap it up. We got the integral of u is going to be u squared over 2, right? This integral in the middle is going to be 14u. Then finally, we're going to have plus 49 times the natural log of the absolute value of u, and we can't forget our plus c, right? Okay, so now we've integrated in terms of u. We need to sub everything back in for x. So let's go way back up here. Okay, so u is equal to x minus 7, right? Okay, well, that means that this is going to be x minus 7 squared over 2 plus 14 times x minus 7 plus 49 times the natural log of the absolute value of x minus 7 plus c. And there we go. That is our answer. All right, guys. So hopefully that helps you a little bit. Remember those techniques whenever you're working problems. You might be able to use them when you get to some tricky integrals. Good luck.